हरिः कर्ता।
So now let's look into the calculation of variance and how to do the variance calculation. So as we have discussed earlier, so variance is a number which gives the spread of your data set. So variance is a number that at first seems complex to calculate, but it can be calculated. So calculating variance starts with a deviation. To calculate variance, you need to understand what is a deviation. Let's understand deviation first. Let's take an example. A deviance is the distance away from the mean of a case score. Let's take this example. If the average person's car costs $20,000, okay, this is the average. We have taken a population data set. So in that data set, we have calculated the mean of the mean of the person's car cost, that is 20,000. It's like we have the car cost of different persons in our population. Out of that, we have calculated the mean and we got the 20,000 USD. Now I have a car which cost around $14,000. So in that case, if I want to calculate my deviation from the mean of the population, so it would be 20,000 minus 14,000, so that would be 16K. So that's how we calculate the average that's how we calculate the deviation. So deviation is a distance away from the mean of a k-score. So it's the formula is yi minus y bar. So yi is the individual score or individual value, and then y bar is the average. Y bar is the mean of the population. Okay, so here in this example, if the average person's car cost $20,000 and my deviation from the mean is minus $14,000, in that case, what would be the car cost of mine? So it would be 6K. Okay, anyway, the deviation is pretty simple. The deviation is equal to your individual value minus of the mean. That's it. That's what the deviation is. Now let's move on to the uh, one example that we'll take from the scores that we take from the IQ scores of class A 13 students. So first, the deviation of 102. So these are the scores, IQ scores of 13 students: 102, 128, 131, 98, 140. So out of that, the y bar of class A, that is the mean of class A, is 110.54. So now I want to know the deviation of a student whose IQ is 102 from 110.54 is how much would it be? So 102, this is what the point of interest, and 102 minus 110.54. So this is what we have to calculate. Similarly, we have to calculate the deviation of a student whose IQ is 115 from the mean. So both will be calculating. Now let's calculate the deviation of 102 from 110.54, that is minus 8.54. So because the student whose IQ is 102 minus the mean of the overall population is 110.54, so you got the minus 8.54. That's what the deviation is. Deviation of that individual. And similarly, if you want to do it for the student 115, student 115, the student who holds 115, that is 115 minus 110.54. In this case we will be getting the positive number. In this case we'll be getting the positive number. This is how we calculate the deviation. Let me put it in here. So let's calculate the deviation. So deviation, we got the mean is equals to 110.54, and we got the two individual values, that's y1 is equal to 112, sorry, 102, and y2 is equal to 115. So now y deviation 1, so deviation for y1 is equal to y1 minus mean. So that would be, yeah, let me do this and execute. So deviation underscore y1 is equal to y1 minus mean, and deviation underscore y1 is equals to minus 8.54. And similarly we'll do it for deviation underscore y2, that is equals to y2 minus mean, and deviation underscore y2, that is 4.5. This is for y1 it is negative, for y2 it is 4.45, and that's what we told here. So minus 8.54 for the y1, and for the 115, that's a y2, that is 4.54. Okay, so this is how we calculate the deviation. Once you got the individual values of deviation, now it's time to calculate the variance. So how do you do that? So now we want to add these to get total deviations, but if we were to do that, we would get a zero every time, because you have mean on left side, you have all values would be negative, on right side all values would be positive. So when you add a negative to positive at the end of the day, you would get a zero every time. So what will we do now? How will we do it? So what we need to do now? So we need a way to eliminate negative signs. What is that? It's a simple squaring the deviations. Squaring the deviations, that's it. You just square the deviation, which will eliminate negative signs. Now finally we'll get the deviated squares, a deviated square. So yi minus y bar square. So now what I'm gonna do, so with this it's not enough for me. So what I'm gonna do, I will square deviated square is equal to deviated power. That's it. This is mine. So now the negative value has been converted into the positive. Now same I'll do with the second one. It's is equal to div y2 power square. That's it. So now you got the both positive values. So now no worries of cancellations. No worries of cancellation. So now let's get back to the example. A deviation squared for 102 is 72.93. That's what we have done it. And for 115 it is 19.89. So there is no negative values. You got the both positive, hence there is no issue of getting zero. Now what's next? So now we have suppressed the negative deviations using the square methods. So now we have to put all the steps together to find the variance, to calculate the variance. That's what is, if you were to add all the squared deviations together, you would get a sum of squares. If you were to add all the square deviations together, you would get what we call the sum of squares. So sum of squares is nothing but sigma of yi minus y bar all square. If you put it in a formula way, sum of squares is nothing but a variance y1 minus y bar all square plus y2 minus y bar all square plus and so on yn minus y bar all square. Let me explain this with the our IQ example, so that would be much easier. So measures of variability, so we are doing the variance calculation with taking the class A IQs of 13 students. So this is what 102 128, these are the 13 students IQs. Okay, 13 students IQs. Now our first case, I need to calculate. We know that. So first we need to calculate the deviance of individual. Once you got the deviance of individual, to suppress the negative values, we will square them. Once you square it, all of individual deviations, you will add together to get the variance. Okay, first individual being for me, anyway, y bar is 110.54. First individual being for me is 102. So I will do 102 minus 110.54 whole square. The negative value be summed up, suppressed up. Then I'll go for the 120. Then I'll go for the 115 here. 115 minus 110.54 whole square. Then I'll go for the 128. Then 139. Then I'll go for the 98. Here is the 98. Then 140. Then I'll go for the 93. Then I have 110 here. Then after that 115, 109 minus 109's deviation, 89's deviation, 106 deviation, 119's deviation, and 97 deviation. So all deviations are calculated and then squared up and then summed up. That's what we call it as sum of squares, and we got 2825.39. That's what the sum of the squares we got. So now it's all done. So the last step, or the last nail on the coffin, it is the approximate average of sum of squares is your variance. That's it. So we have seen the 4 steps. The first step is calculating the deviation. To suppress the negative deviation, we use the squaring method, and then after that we have summed up all the squares, and finally you divide the sum of squares with the total number of observations or records. You will get your variance. That's it. The average sum of squares is your variance. So now there are 2 types of variance: variance for population and variance for sample. Variance for population is pretty simple. Sum of squares divided by number of records or number of entities or number of observations of that population. That is sum of square divided by n. But when it comes to the sample, variance for a sample, it's slightly different. You have to divide a sum of squares with the number of records minus 1. That's n minus 1. Okay, capital N represents the number of records of the population, whereas the small n records the number of records of the sample. Okay, so let me put it into the formula way. So variance is equal to sigma of yi minus y bar whole square divided by n minus 1. This is for the sample. This is for the sample. So now, so we'll get back to our previous example for class A. So we got the variance is equal to sum of squares, that is 2825.39 divided by n minus 1, because that's a sample out of our population. So now when I do, let me do that. So sum of squares we got around, so all sum of squares is equals to 2825.9, and then total records for me is just, I'm looking to 39, and then records is 39, and then total observations or population size, or simply sample size is 13. But for us, variance is equal to sum of sum of squares divided by sample size minus 1. So that's what our variance. That's it. It's 235.44. Fantastic. We'll round it off to the 235.45. But the question arises, how helpful is that to me? What can I make out of it? What I can infer from that? That's the question, because your values, your scores are between 80, 90, 100, 140, 130, and you got the variance of 235.45. What does it make sense? If it makes sense, what way? For me, it doesn't make much sense. 235.45, which directly there is no connection with the scores that we have defined earlier, the score values that we have seen earlier. So that's the reason for me. I don't think, I'm worried. How does it help me? How does it help me, and how helpful is it?